will be applications of our data science in healthcare. So main my area currently I'm working in machine learning in healthcare. So here I will first introduce some applications of data science in healthcare. Then I will briefly tell you about data science, and then I will just try to touch machine learning, and then I will let you know about what exactly the predictive analytics. And if time permits, then I will let you know about the brain stroke case study, how we predict the response variable. So here, very first area of healthcare machine data science in healthcare will be it is the medical image analysis. So we all are aware of these images, right? The first one is the X-ray image, the next one is the MRI image. So what we get from this? So currently IBM has estimated that the medical images contains around 90% of the overall medical data. So various imaging techniques are available, just like our MRI, that is magnetic resonance imaging, then X-ray, then CT scan. So here they actually what they do, they actually predict, they actually depict the inner working of our human body. So here conventionally what was happening, so doctors were analyzing these images manually, like they see the images and based on their experience they were telling ki whether the person has any particular disease, is there any abnormality found, is there any abnormality that is existing in the X-ray image. So it was done manually previously. If the new doctor is there, so there is a chance that he is not that much experienced one, and so because of that he may ignore some basic or macro level information. So here what will happen, they were sometimes unable to diagnose tiny abnormalities. But nowadays what is happening, so deep learning technologies in the data science have made it possible to detect such abnormalities, that is microscopic deformities in the scan images. So medical image analysis is the main field where nowadays machine learning is playing important role. So the next one will be, so here actually how we analyze the image. So all the images will be taken. Then we have to divide our process in two parts. The one is we have to clean the image. So for cleaning of image means we have to enhance its quality. We have to segment that image for particular part. Then we have to denoise that image. Any not required data is there, or any noise is there, we have to remove that. Once we have the clean data, clean images, then what we can do, we can apply our different algorithms so that we can get some insight from those images, and we will be able to give some outcome, or we will be able to predict something or interpret the results according to our convenience. So these are the two stages in case of medical image analysis. The first one is the image processing, and the second one will be our application of different algorithms. So then the next field, the first one which I have recently I have now told you, that is the medical image analysis. Then second field will be it is the genomics. So what is genomics? Actually our human body, the body is made up of different tissues.
Snehal ma'am, sorry to
Yes.
interrupt, but if I'm not wrong, the slides aren't moving. You're still in the first slide.
No ma'am, I have come to the second field. Just seconds, let me stop the sharing, then I can have this. Is it visible now, ma'am?
Yeah, right now it's in genomics slide.
Yes. So the
Okay,
second
okay, ma'am.
area
Thank
of,
you.
okay, ma'am. The second area where we can apply our machine learning knowledge is in the genomics. So our body is made up of basically tissues, and which are made up of cells. So if you observe this diagram, here we have the cell, and in that cell we have the nucleus. So here you can observe some thread type of structure. So this is called as a chromatids. So here when division happens, these threads will acquire some proper structure. So this proper structure is called as a just a second. So this proper structure is called as a chromosome structure. So in one cell we have 23 pairs of nucleic acids. this chromosomes. So if you zoom in this chromosome structure here, we found that there are genes. Again, if we zoom this, we can found here there are DNA molecules. So our main task is to understand these DNA molecules. So what exactly these DNA molecules are made up of? So these are like helix type of structure. So if you observe, this is a coiled strands. So here this is a helix structure where it has four bases. The one is the adenine, cytosine, guanine, and thymine. So here this structure is formed with this four molecules. So here always there is a bond type of structure. So if there is a adenine here, it will be bound to the thymine. So adenine always forms bond with the thymine, and cytosine always forms bond with the guanine. So this is the basic DNA structure. So if you see in one person, this type of DNA structure is observed. So AGCT are the four base pairs, base molecules that are observed. So if you observe this person with this person, so here all the DNA, this sequence. So this is like DNA sequence. So in that DNA sequence, how the base pairs are arranged. So if you observe this two person, there is a small difference. In here there is a C, here there is a T. So rest of the molecules are same. So this is a simple small variation. So this small variation makes this person look different from each other. So now if we observe in our like population, all two people, if we consider two people, 2 persons, the 99.99% DNAs are same, only 0.1 variation is there. So that because of that variation, we have different taste from each other. Like some people may like broccoli, some may not like. Some people appearance has one person appearance is different than other person. So this 0.1%, this sequence difference will make every person different from each other. So here, if this variation may lead to the disease, or it may affect the health of the person. So for that purpose, we have to understand this DNA sequence. So for that purpose, we need to study the genomics. So the aim of genomic study is to find the characteristics and the irregularities of the DNA. So researchers can use this DNA sequence to search the genetic variation, and a single base pair or the 1,000 base pair replacement, deletion or insertion can cause the disease. So as we have seen, if there is a single pair change is observed, that is not defined change, so that may lead to the disease. So there again there are two fields. One is a genetic field, another one is a genomics. So genetic is we are studying only one gene, but here in case of genomics we study the complete genetic material of an organism. So here we in case of genetics, genes are involved in the development and functioning of body. So here they focus on this, how the body will be developed. So here entire genome structure will be considered. So this genetic study involves single gene, as I already mentioned, and genomics involve the complete DNA structure. So here, so before the powerful computation, organizations spend time and money to analyze these gene sequences. So genomic data science uses different nowadays. We have different computational and statistical approaches. With the help of that, we can decode the information of this DNA sequence. So here, different data science technologies enable the academics and physicians to understand how DNAs affect the health disease. Then third application. So as till now we have seen two applications. One is the medical image analysis, and the second one is the genomics. Now third application of data science in healthcare is discovering drugs. So here drug means like just if we have some infection, what we do, we mostly take the tablets. So how in case of laboratory setup, different tablets are prepared, but out of all those tablets, which are effective for particular disease. So how we can get to know about that? So for that purpose, different things are done at the back end. So to avoid that, we have data science, which will help the person to detect the proper tablet for particular virus. So here drug discovery means, so drug development, what a drug development is, it focuses on finding cures for disease related targets. So here target is the virus. So for particular disease, what is the target? Which virus is affecting the human body? So drug development will help us to study that part and then making disease. So for because of that, we can manage the viruses and diseases easily. So drug discovery turns out to be the time-consuming procedure as it involves the investment. So here, as I have already mentioned, different drugs are prepared, and out of all those, only few are selected as the final product. So here, that means here testing and in testing investment is there. So here, data science. So what we will do in case of data science, we can simulate the drug that affects the humans, eliminating the extensive lab research. So we can simulate the drugs which will affect the body, and based on that, we can select particular drug. So here, pharmaceutical data science model helps the companies to understand their patients, and they will also help they will also help that what type of care they need to take, so that the patient will get healthier faster. So here, in case of drug discovery, there is a one important model involved, that is quantitative structure activity relationship model. So in that model, this is actually machine learning classification and regression model. So in this model, what we will do, we will take the molecules. So this is the molecule. So this is the physiochemical relationship between the, in case of particular molecule, if particular bond is present or not, what is the size of that. So different the chemical characteristics are considered, and based on this, some descriptors are formed. So this is the descriptor of first molecule. This is the descriptor of second molecule. So after in case of Y, so these are the different features of particular molecule, and this is the label. If these are the features available, whether this molecule is active or inactive. So 1 is active, 0 is inactive. So based on this, we will take the all molecule data, we will train our model, and once our model is trained for different molecules, we can give new molecule as an input, and we will predict whether this molecule is active, it will be active or inactive. Again, we can focus here on the different features as well, like different characteristics of the that particular molecule. So in this way, we can use this quantitative structure activity relationship model in case of drug discovery. So here this will tell. So here this model is mainly used in the drug discovery to identify the chemical compound with good inhibitory effect. That means which chemical compound has good effect on the specific target. So here specific target is the virus. So where it is preventing, which chemical compound is preventing particular virus. So that is the meaning of this, and which has low toxicity or non-specific. So as we already aware of cancer, like chemotherapy, they are affecting our non-specific. They have non-specific activity as well. Non-specific means there is a hair loss. That means specific means it is related to virus, and non-specific is our normal structure of our body. So specific virus related. So it should have good prevention. This chemical compound should have good prevention for virus, but low prevention for our non-specific. That means our original body. It should have low toxicity for our normal body, but it should act very faster with respect to our virus. So this is how we define the chemical compound with the help of this type of model in case of discovery of the drug. So here, these are like this model is also called as a regression and classification model. So now, till now, we have seen three applications: medical image analysis. The second one was genomics, and third one was drug discovery. The next is the patient health monitoring. As we all are aware of this, like we are wearing different watches, then different wearable devices are there, belts are there. So what actually we do? So based on this, if you observe this diagram, with the help of these wearable devices, the data of person will be, or the particular patient will be collected. So what type of data? What is the heart rate, pulse rate, then respiratory rate, then breathing rate, body temperature? All this data is collected. So this data is stored in the cloud services for further analysis. For different persons, for the particular device, we collect the data, and we we analyze the data and we classify, we predict whether this person is vulnerable to particular disease or not. So based on that, the process could, so in the last phase, if any abnormal event is will happen in the near future, so that can be defined at the last stage. So here diagnose and treatment will be defined. So first we collect the data, we store the data, analyze that data, and then we diagnose any problem is there or not, and then based on that we can suggest some treatment. So here this fourth field of application of healthcare is patient health monitoring, and the next one is disease monitoring and prevention. As we are already aware of heart diseases, how people are predicting the heart diseases based on the data set. So here, so in what it is then, so in many extreme situations, diseases, if they are not detected at an early stage, so what will happen? It has a negative impact not only on the patient's health but also on the economic cost. So data scientists, so what data scientists will do? They will use the powerful predictive analytical tool to identify the diseases. So here, if we observe, so in case of researchers at Brazil University in company, they what they do, so what they have done, they have in particular hospital, there is one hospital, so different at that point, at that time, different patients, people were affected by the Zika virus. So what they did, they collected almost around 223 patient data, and their metabolic using their metabolic markers. So they collected that data, and based on that metabolic markers, they identified, they trained their model, and they with the Zika virus. So what they, whenever a new patient has been admitted to the same hospital, what they did, they directly without going for directly like a manual checking, what they did, they provided the data to this AI model, and that patient will be either classified with the in two categories, whether he is infected with Zika virus or not infected. So this Brazil University has come up with that AI platform to detect the Zika virus. And then next, different companies are working on this. So IIIT is one of them, which will help to detect the autoimmune diseases. And the last one will be the virtual assistant. So here, what is virtual assistant? Through the mobile, this is like virtual guru. So if we have any problem, we are telling that problem to someone, and that person, the person will suggest us the treatments. So here, so this is mainly useful with respect to depression or anxiety. So here, what happens with virtual assistant? So disease prediction, data modeling has helped data scientists to construct an extensive virtual platform to treat the patients. How which type of patient? Depressive, then anxiety related, then neurodegenerative diseases like Alzheimer disease related patient. So what they do? So they allow the patient to register their symptoms and receive the disease information based on their confidence level. So that they register the patient, and the patient will tell the symptoms and the data related to the disease, and based on that they will get the treatment. So here Berlin based startup is there currently. So what they do, they are predicting the diseases based on the user symptoms. So that is the well-known example of Berlin based startup. It is the well-known example of the virtual assistants. And then the Wobot is there, and the Stanford University chatbot that provides the therapy treatment based on the So here, as we can observe, in all the thing, like we have observed 6 applications. So what are those? The first one is medical image analysis. The second one was genomics, then drug discovery, then patient health monitoring, then detecting different diseases. In that we have seen the Zika virus prediction, and then virtual assistant. So in case of this, we observed that in case of healthcare, because of electronic records, then different lab records are there, lab reports are there, then different medicines are purchased by different people, different investigations are there. Because of this, large amount of data has been created. So here, as healthcare has large amount of data, so we can get benefit of that. Like we can take that data and we can propose our own model so that it will help the healthcare field to diagnose the diseases diseases very precisely. So here I will share this PPT with the ma'am. So I have enlisted some real-time data sets that are mainly available with respect to healthcare branch. So biology data sets that are available. So I will just play 2 minutes video. This is recently uploaded by Sundar Pichai, sir. So ma'am, just tell me if you can hear the voice of this.
Yeah, okay, ma'am. No, I mean, if the video is on, we are not able to hear the voice. I think while sharing, there's an option called include computer sound. You have to enable that
Uh,
on top.
so
While sharing,
we announced Google
first
AI.
one is computer.
Collection
Yeah,
of
yeah.
our
Sound is on.
okay, ma'am, fine.
teams and efforts. Last
So this is very recent video. So you can just see how Google AI has developed their models to detect the diabetic patient or retinopathy.
year at Google I/O, we announced Google AI. It's a collection of our teams and efforts to bring the benefits of AI to everyone. And we want this to work globally, so we are opening AI centers around the world. AI is going to impact many, many fields. And I want to give you a couple of examples today. Healthcare is one of the most important fields AI is going to transform. Last year, we announced our work on diabetic retinopathy. It's a leading cause of blindness, and we use deep learning to help doctors diagnose it earlier. And we've been running field trials since then at Aravind and Sankara hospitals in India, and the field trials are going really well. We are bringing expert diagnosis to places where trained doctors are scarce. It turned out, using the same retinal scans, there were things which humans quite didn't know to look for, but our AI systems offered more insights. Your same eye scan turns out holds information with which we can predict the 5-year risk of you having an adverse cardiovascular event, heart attack or strokes. So to me, the interesting thing is that more than what doctors could find in these eye scans, the machine learning systems offered newer insights. This could be the basis for a new non-invasive way to detect cardiovascular risk. And we just published the research, and we are going to be working to bring this to field trials with our partners. Another area where AI can help is to actually help doctors predict medical events. Turns out doctors have a lot of difficult decisions to make, and for them, getting advance notice, say 24 to 48 hours before a patient is likely to get very sick, has a tremendous difference in the outcome. And so we have put our machine learning systems to work. We've been working with our partners using de-identified medical records. And it turns out if you go and analyze over 100,000 data points per patient, more than any single doctor could analyze, we can actually quantitatively predict the chance of readmission 24 to 48 hours before, earlier than traditional methods. It gives doctors more time to act. We are publishing our paper on this later today, and we are looking forward to partnering with hospitals and medical institutions.
Okay, fine. So can you hear me?
Yes, ma'am, you're audible.
Okay, I feel like that video is a bit interesting because I found that video very interesting. So that's why I thought to share that video. So we can observe that, like, if we compare the doctor, what they are doing manually, but if we feed that much of data and if we predict the diseases properly, then survival rates will be definitely it will get increased in nearby future. So fine that Google AI, they are very nicely working in that field. Um Okay, fine then. So I will briefly introduce you as this is like second day. Maybe you are already you have been introduced by like with this data science. So again, I will let you know about the basic things. What exactly we'll do in the data science. So if we consider, suppose this is like Suppose suppose a person has hotel, they have the restaurants in New York and San Diego City, and they are collected the data of revenue that is generated for every month. So for all 12 months, they have generated this much of revenue. But here, only with this Excel sheet, we cannot identify anything from this. So, but suppose if I use the Excel plot, if I plot this in some visually, then what will happen? So suppose if I try to observe this data, so what do you observe from this? So New York is not performing that well as compared to the San Diego. Everywhere in San Diego, we have good revenue, but in case of again, in case of from June to September, as in summer, we observe that there is the New York restaurants are not perfectly working. So here, this is our original data in a tabular form. With that, we cannot observe anything. But if we plot that data, we can easily understand what we can do. We can get the insights from the data. So here, what will happen? We have the data. We try to plot the data with the Excel sheet. So by that visualization, we can get some insight. We observe that New York restaurants are performing poorly during the summer. So what we can do then? We can run some special promotions in New York restaurant during summer so that I can increase the revenue. So this is how data science is helping. So here we can observe that this is a tabular form. With the visual form, we can get the insights and we can get some benefit out of it. We can design or we can decide something that what we can do with the in the future. So here, this is the data that is plotted in an Excel sheet. So if you observe this diagram, so there may be the conclusion. Many of you, if you are listening, so there may be the conclusion that a big person, the small kid is trying to control the big person. So what we can tell from this? Anyone from you? So what I have told you, this is a Excel. In the Excel, we have stored the data. That is a small amount of data, and we are trying to plot that data. And the next diagram is the fat person. The kid is trying to control the fat person. So what I can conclude from this, nowadays, if you observe the healthcare, large amount of data is available. So here, can we store that data in Excel? Can we observe, can we visualize that data? So if you have suppose 10,000 records in a Excel, and I try to plot that bar chart in the Excel, so or pie chart in the Excel, so will I be able to do that? No, because there are 10,000 records, so Excel will get hang. So here, managing huge data using Excel will not work on the data. It will stop working. So for that purpose, we need to adopt some different technologies. So there are different tools. So here there are, again, I will mention, there are huge opportunities in case of data science. So if the students or the many faculties, they may want to switch for the industry or corporate, so they can also, this presentation may be helpful for them as well. So there are different opportunities by 26. So after 26, again, there will be the saturation in the corporate. So here, so if you want to be data analyst, so you have to know what is Python programming, what is the R programming. So these are the tools that are used for data analysis. So if you want to get into the data store and data storage and distributed computing, so you should have the knowledge about Hadoop and Spark Apache. That is mainly used for the distributed system. So HDFS, the distributed file system is there, big data Hadoop. So here, visualization. So if you want to visualize the data, so you need to know what is Power BI, what is Jupyter, then what is Tableau, then Matplotlib. So with the help of these tools, you can visualize the data very easily. And the last one is the predictive analytics. So for predictive analytics, we need to learn the scikit-learn and TensorFlow. So who has developed the Google Summer of Code? So every year, Google Summer of Code competition is there. So the one person has participated there, and he has come up with this scikit-learn library. So nowadays people are using that scikit-learn library for machine learning project and TensorFlow. It is developed by Google Brain team. So here, so for predictive analytics, we need to know about this scikit-learn and TensorFlow. So here, there are different types of data analytics. So the first one is a descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Descriptive means it deals with the what happened in the past. So it is just description about the past, what happened. Diagnostic means why did it happen in the past. So we have to diagnose why it happened. And in case of predictive, what will happen in the future. So descriptive and diagnostic that deals with the past data, but in case of predictive analytics, with the help of past data, we need to tell what will happen in the future. That is predictive analytics. And prescriptive means we have to decide whether to avoid this, what decision we need to take. So that is prescriptive analytics. How can we make it happen like that? So here, the basic predictive analytics is, it is a branch of advanced analytics. So what it deals with, it uses the historical data, then different modeling techniques, statistical modeling, different data mining techniques, and machine learning techniques. So to gain the gain insight from the historical data, so data scientists will use the deep learning to predict the future outcome. So here, some of these are the different techniques: logistic regression, linear regression, neural network. So again, about machine learning. So you are already aware we have to make the machine to learn. So here, this is the basic definition of machine learning. That is a computer program. Please listen this definition carefully, because many people fail to understand this definition. So I will explain this definition with the help of very nice example. So here, a computer program is said to learn from experience E with respect to class T and the performance measure P. If its performance at task in T as measured by P improves with the experience. So you have here experience, we have here task, and we have here performance. So here TP, it is again called as a task performance and experience model. This is the definition given by Tom Michel. So here I will explain this definition. So here task is, I want you to identify the names of this fruit. So maybe every one of us will be able to identify which type of fruit is this. So here I will give the names. Why you observe, why you correctly like correctly told me the, like, in your mind maybe told me the correct names of these fruits, because you okay.
Snehal ma'am, I think you're muted.
Now, ma'am, can you hear me, ma'am?
Yeah,
Maybe
now it's
because
okay.
okay,
Okay.
fine. Thank you, ma'am. So here, what I have told, you could identify the names of this fruit correctly because you have already aware of these names. But if I give you the new fruits, you will not be able to identify because you have not come across with these fruits. But what will happen if I will show these fruits to you? Fruits images along with their names, so you will not be able to currently will not be able to identify. But if I give you the names to these fruits, and what I will do then, I will pick 3 students, and I will again show all these images, 5 images to the students, and I will ask 3 students, all these 3 students to give tell me the names of these fruits. So what will happen here? The task is to identify the fruits in the images. Then experience is you need to remember. I have already shared the names of the fruits with you. So you have to remember these names of all these fruits. The next one is I will ask the students to identify these fruit names again. Then what I observed, student one, what he did out of all five students, out of five fruits, he identified two fruit names correctly. Then second, for second student, he could identify three fruit names correctly, and the last one is four names correctly. So can I say that student three is somehow intelligent as compared to two students, because out of five fruits he could identify four fruit names correctly. So this that I have concluded that the student three, he has 80% accuracy, that he has correctly identified 80% of the data. Then student two 60% and the student one 40%. So here the same thing will happen with the machine learning. So what we will do, we will give our data to the machine and then we will train different models. So there are different models, SVM model is there, logistic regression, linear, different models are there. And based on the performance of the model, like how much accurately my model is fitting for particular data. So based on that, I am deciding that particular model. So this is how. So here, this is the TPE. Task was to identify the name of the fruit. Performance was, I have given data to the three students and I analyze the performance. And experience means I have shown the names to the students, and based on that, student has remembered, they have remembered the names of the fruits and they could identify it later on to design the performance, to define the performance. So here I will ask, so what I will do, so I will ask the machine, can you do the same thing for me? So as we have done it manually, because for only five images are there, so students I can easily identify, but I want machine to do this for me. So what machine will do? It will answer that, sure, I will do this for you, but what you do, you feed me the data. So that is what machine learning. So here, these are our traditional algorithms and these machine learning algorithms. So what traditionally happens, just our C program, what it is, a set of rules or set of instruction, and one by one, every instruction will be executed and we will get some output. So here, and we will give the data, then set of instruction, and based on that, we will get the output. But in case of machine learning, what will happen? We will get the data. So I have given you the images of the fruits images. Along with that, I have shown you the names of every fruit. So I will give this images with the names to the computer. Then computer will learn. So if this is the shape of the fruit, it will be apple. If this is the shape, if the orange is the color of the fruit, circle is the shape, this is the orange. So like that, computer will learn this data. It will be trained on this data. And if I will give new input image of any fruit, then model will be able to tell me what type of fruit it is. So this is how machine learning is working. Again, in case of machine learning, there are three parts. One is a supervised learning, unsupervised learning, and semi-supervised learning. So mostly we use this type of learning technique, supervised, that is classification and regression techniques. So supervised means the word itself tells, it is a supervision. So some supervisor is available there. That means for our data, the names are available. So for our fruit images, the outcome label, that is outcome name, what type of fruit it is, that label is available. That is supervised learning. And again, in that we have classification and regression. Again, unsupervised learning. So we will not giving any name to the fruit. We will only feed the images to the computer, and that is unsupervised. So here again clustering. So neighborhood, hierarchical, and DB scan clustering. So here in case of, as I have already told, in case of supervised learning, we have to find out the relation. So this is these are the features along with the label. So what are the features with respect to our fruit image? What is the color? What is the shape? What is the height? What is the width? What is the weight of fruit? All these are the features. And for this feature, which type of fruit it is. So this data will be given to the computer. So on this given data, the model will be trained. And for that particular trained model, what we will do, if we'll give some new features, So it has to give me what type of fruit it is. So if you consider about our one example, I will give you, explain this with the help of example, that is health related, cancer related example. So here tumors are there, and there are two types of cyst in our body. The cyst may be benign type or it may be malignant. Malignant means cancerous, and benign means it has no any side effect on the body. So here tumor. So based on that cyst data, what it has radius, it has volume. So here I have included only two parameters. Plenty parameters are there. So here, if this is the radius and this is the volume of the tumor, then that tumor is malignant. So this is the supervised machine learning. Why? It is a classification problem in case of supervised machine learning, because here we have some binary classification. Only two classes are there, and the data is any type of data will be there. It may be categorical data, it may be numerical data. So based on this feature data, we are predicting whether the outcome label is of particular type or if it is not. So here features are radius. In case of our fruit example, fruit ka color, then its height, weight, then different parameters are there. Those are considered as a features. So in case of this example, if we consider this single record, so this radius, this volume, these two are considered as a features, and the category is considered as a response variable, or you can call it as a dependent variable. It depends on this independent variables. So here it is a response variable or predictive variable, and here the label will be category. So here supervised again regression. So here we have seen it is a classification. It may be of a malignant type or benign type. But what will happen in case of supervised machine learning? We have label which is numerical one. Numerical in the sense some continuous value. So it is not fixed value. It is not discrete value, either 0 or 1, 0, 1 or 2, like that. So here it may be some continuous value, 30,000. If the qualification is MS, experience is 5 years, then he will have this much of dollars of salary. Then BCS, this much of year experience and this much of salary, like that. So here these are considered as, this is considered as a features for this record, and this is a continuous variable. So if it is a continuous variable, it is called as a regression. Again, in case of unsupervised learning problem, so as I have already mentioned, in case of supervised learning, here we are giving features along with the label to the model, but here we are only giving the features. So feature, and then based on the feature, we are finding some relations, and we are putting data in different cluster. So this is the simple example. If I will give you all the data together, what you will do? So you will cluster this data in three clusters. So three types of potatoes are white potato, brownish potato, and then somehow blackish potato. So this type of clusters will be formed. So this is my input data, and this is my output. So different clusters will be formed. So this is unsupervised machine learning. So exactly what will happen in case of machine learning? So simple example I will tell with the help of decision tree. So what is tree? It is like parent and child relationship. And what is decision tree? So if there is a decision, so this is a tree, and this is a, if there is a decision, so base for that combined we can call it as a decision tree. So here for every branch we have to take the decision whether we should go left side or right side, and based on that finally we will have here outcome label at the leaves. So here this is very standard example of flowers, iris flower. So I have taken simple example exactly how decision boundary will be formed and how model will be trained. So in case of this flower, there are four actually if you go for this original data set of iris, so that is balanced data set. Balance, again here is a concept of balanced data set. Balance means if we consider the classes, so if we have 300 records, so and 3 classes, so every class should have 100 records. 100 Setosa record, 100 versicolor records, and 100 Virginica records. So that is data, our data is balanced. So in that there is data is balanced. Original iris data is balanced one. So here it has 4 features. Out of 4 features, we have collected only 2 features, that is sepal. So sepal length, sepal width, and this is a petal feature, petal length, petal width. So here, so I have what I will do. I have drawn this diagram for this color, this fruits. So here there are 3 ways how we can interpret the decision tree. One is a visualization, second one is tree based and program based. So if you go for visualization method, so here I will only create the 2 boundaries based on length and width, and based on the boundary we will decide whether our flower is of which type of our flower is, whether it is virginica, setosa or versicolor. So here this is the in case of visualization we are plotting the decision boundary surface. So in case of tree based method, for this W, with the help of this W and L, for original, if we consider any new sample, sepal length is given, sepal width is given. Our model is trained on this with the help of decision tree. So we have come up with the main W value and length value. So if I will give new sepal length and new sepal width, so what will happen? I will compare this sepal length with this what our model has come up with. So sepal length, if it is less than L, I will come to this boundary, this area. Again, if I come to this, so I will come here. If it is less, I will come to this side. If it is greater, then I will go to this side. So this is a decision which I have taken at this level. So for root level, I have decided to come at this side. Then sepal width. So once I compare with one feature, I will compare with the another feature. So what is another feature? Sepal width. So again, sepal width, I will compare with the originally which I have got with my model. So sepal width with the original width. So if my width is already, I have concluded that by coming at the second level, I have concluded that my sepal length is less than this. So now I am here. So here I will compare with the width. So at this point, I will compare with the width. So if my sepal width of new sample is greater less than this means I will come here, this plot. So this plot here I have got that there is a setosa flower. So like this we can predict the new sample. So based on original data, whatever original data I have created this decision boundary, and with the help of this opt-in parameter, that is width and length, optimal width and length, I have predicted the new sample. What type of new sample is. So whether it is which type of new sample, whether it is virginica, versicolor or setosa. This is the tree based example, and the next one is a program based. So again, it is just in case of decision tree, it is just if else statement type of program. So again, recently I have collected the data of brain stroke, cerebral brain stroke. So it is like this. So if you want, I will share the data set with you and Google Colab file as well with you. So which I have. So after the lecture, I will share that with the Divya Meena ma'am. Then she will share with you. So this is what I found is very nice case study to learn for to go for the machine learning, because this data set is imbalanced data set. It has missing values. It has some missing values. Again, it has some outliers. So everything is there in this data set. So I feel like you should go for this. So this data set, it has this 11 features. So gender, which type of, if the person is male, whether he is male or female, then what is the age of patient. So if he has hypertension or not, it is categorical variable. Categorical feature means whether the person has hypertension or he does not have. Then next one is heart disease, whether he has or he does not have. Then again, this is categorical variable. So then married, whether married or not. So I feel like if person is married, there is a chances of heart stroke, not heart, the brain stroke. So you can observe that 3353 patients, those are married and those are having stroke. So if you observe the data, this is imbalanced data. Later on, you can balance and observe the data. So then again, work type. So private, whether the person is working in private company, self-employed, or a housewife, or government job, or never work. Then a residence type, whether he belong to urban area or rural area. Then glucose level. So what is the glucose level? This is really very important parameter, glucose level. Then BMI, then smoking status. So here smoking status is whether he smoke, never smoke, or smokes, or unknown. And then the last one is a predicting variable. So today's topic is predictive analytics. So we are predicting what will happen in the future. So if these all 10 features are given to my trained model, I want to predict. If I give the new data to my model, I should be able to predict whether that new sample will have brain stroke or not. So that is the predictive analytics. We are predicting something in future. So this is the data. Then here this data, in case of data pre-processing, what we have to do, we have to remove the missing values. So in this we have BMI, in the BMI we have missing values. Then outlier. So maybe you are aware of outlier. So I will again tell what is outlier. So suppose we have age from 1 to 100, but because of some human error, someone has entered age as 1,000 years. So we have all values. Suppose we have 300 records. All 299 records have the values ranging from 1 to 100, but only 300 last record, his age is 1,000. So that is some outlier. It is far away from our original data. So this is outlier. This affects the final accuracy of our model. So we have to detect the outlier and eliminate that record. So last record we have to eliminate so that our model will perform well. So here outlier identification defines the observation that differ considerably from the normal and other values. So in this data set, these outliers are identified and they are removed. So this is imbalanced data. So what is imbalanced data? As I have already told, we have two classes, stroke and stroke. We will not have stroke. So here you can, this is with stroke and this is without stroke. So we have very less records available with us. Those are having stroke and these are without stroke. So we have to first, we cannot train the model. Everyone, please remember, if you are working in machine learning area, we cannot train the model in imbalanced data. Your model will be, it will not be properly trained. You will get the wrong results. So before going for data, before directly going for applying model, we have to check whether data is balanced or not. After that, so for data balancing, there are different techniques: undersampling, oversampling, then SMOT. Again, new technique is there. SMOT ENN is there. Edited nearest neighbor technique. So different techniques are there. So with the help of those techniques, so in case of SMOT, what we will do? So if you have this positive labels listed in our model, and these are the negative. Negative means without brain stroke, and these are with brain stroke. So what we will do? We will randomly take two samples and we are synthetically generating new sample here. So based on the nearest neighbor, we are assigning the label. So in this way, we can generate the data. So to analyze the performance of our final model, we use this confusion matrix. So maybe you all are aware what is confusion matrix, like true positive, false positive. So we should have higher value here. And these are the errors. So here this is like true positive means the person is sick and our model has correctly identified it is a positive. Positive means he is a sick person, and true negative means he is healthy person and our model has identified he is healthy or not sick. So what is false positive? False positive means he is identified, so he is healthy people. He is the person who is healthy. But he has the model has identified it as a sick person. So negatively. So here healthy people incorrectly predicted as a sick. So here this is type 1 error and type 2 error, and based on these parameters we can get the precision value, record value, and we can calculate the accuracy. As we have observed while explaining the example of fruit names, I have told that student 3 is performing well. He has identified 80% of the data correctly. So based on this accuracy, we can understand which model is performing well, and that model we can consider as the base for prediction of new data. Okay, then I will end here. If you have any doubt, please let me know. Yes, ma'am.
Yes, ma'am. 1 second.
Okay.
Okay, ma'am, am I audible?
Yes, ma'am. I can
Yes,
hear you.
ma'am. Yeah, okay. So I think the mic option is enabled for the participants now. So if you have any queries, you may ask Dr. Snehal ma'am now. Just try once and let me know. I mean, please kindly raise your hand if the mic isn't disabled or if you want to ask any queries. Hopefully we enable the mic for all. You can unmute and ask. Okay, so I would take that as a no question. So maybe, okay, Dr. Suresh, PhD, 1 second. Okay, I think it's not enabled. Fine. Sir, you can unmute and ask your query. Suresh, sir. Dr. Suresh, I think you can unmute and ask your query. I see you raising your hand. Okay, I think it should have been by mistake. Okay, I don't think there would be any queries because as you were explaining so clean and clear, I hope there wouldn't be any queries at all. I'm so happy that you taught us in a very layman way. Like even anyone who didn't understand also will definitely understand the session for today. Thank you so much, ma'am. I know your busy schedule. Despite all your schedules, you would try to just adjust this session for us. And a very big thank you for all that. Thank you, ma'am, again.
Okay. Thank you so much, ma'am. Thank you.
Yeah.